So let's look at a few examples of simplifying product and quotient rules. So we're going to look at the quotient rule first because that one is more fun. Remember what the quotient rule says. It says if you take the derivative of some function divided by another function, g of x, and the derivative is also a quotient, and in the numerator is the derivative of the numerator times the denominator, minus, you leave the numerator alone and multiply by the derivative of the denominator. And then in the denominator, you end up with the square of the denominator. So that's the quotient rule right there. And the key thing I said the other day in remembering this is that the subtraction always goes with g prime of x, because that's in the denominator, and that stems from a version of the power rule that I'm going to prove more carefully in a couple of days. But that's related to the derivative with respect to x of 1 over x is the same as the derivative with respect to x of x to the negative 1. And the power rule actually does apply to that, even though I didn't prove it. And that would be negative 1 times x to the negative 2, or negative 1 over x squared. So here's the negative initiating itself there, and you see the square of the denominator here and here. So it's related. The quotient rule basically is a relation to that simpler problem. All right, so let's do one. Let's take the derivative with respect to derivative with respect to x of, let's try 3x squared minus 2x plus 5 divided by 2x plus 3. So we have a denominator that we're kind of stuck with here. There's really not too much we can do to rewrite this algebraically to avoid using the quotient rule. Sometimes that's possible. You can rewrite algebraically and avoid it. I did that in an example the other day, but here I'm kind of stuck with it, so I just got to go for it. So the derivative of the numerator is going to be 6x minus 2, and I leave the denominator alone as a multiple. And then I subtract, leave the numerator alone, multiply by the derivative of the denominator, which is just 2 in this case. And all of that is divided by the square of the denominator. So that's the first stage through. And some homework problems will accept that answer, but on a test, I wouldn't accept that. So we got to do some algebra next. Now, if you think back to your days in algebra classes, so in an Algebra 2 class, cleaning something like this up, you would not distribute the denominator. You would leave that in factored form, but you do need to distribute and combine like terms in the numerator. So for the first pair here, what do we get? We get 6 times 2 is 12x squared, and then we'll get minus 4x plus 18, and wait, no, 6 times 3 is 18. 18 minus 4 is 14. So I'm going to have plus 14x minus 6. And then here, I have to be careful that I have to distribute the minus and the 2. And that's a common mistake people make, is they kind of forget about that minus and only apply it to the first term. So that's going to be minus 6x squared. And then I'll have a negative times a negative, so that'll be plus 4x, and then negative times a positive should be minus 10. All right, how's that look, everybody? Does it look like I did okay? And the denominator, we're just going to leave it as 2x plus 3 squared. So we're hoping maybe something might simplify and cancel out on the top. Okay, so what do we get next? 12x squared minus 6x squared, so we have some like terms. And a lot of times I'll circle and color code those on my paper. So I got those two are like, and that gives me 6x squared. And then we've got the 14x and the 4x. And so that's going to be what, 18 x, and then -6 minus 10, so I switched colors, is -16. And we should see if the numerator factors. So first thing I would do here is notice that they're all even and pull out a 2. So that's going to give me 2 times 3x squared plus 18 is 9x minus 8 all over 2x plus 3 squared. And let's see, does that factor? 3 times 8 is 24. So I've got -24. Factors are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And they are being subtracted. And none of them give me a 9. So the numerator is not factorable. All right, so this will be the final answer here. Unless I have an error somewhere. How do you check? Well, you could whip out something like Wolfram Alpha or the derivative calculator to check your answer, or you could pick a point on the curve and see if this gives you the slope of the tangent line at that point. So let's suppose you were asked to find tangent line at x equals, how about 2? So let's go over that. You don't want to factor the denominator. So the denominator is factored. The denominator, you don't want to multiply it out though, because that is a waste of time. The only time you can tell if something cancels numerator and denominator is if the numerator and denominator are factored, and the denominator is, right? That's 2x plus 3 times 2x plus 3. And do not distribute that. It's a total waste of time. The only way to check if something cancels numerator versus denominator if you can see the factors. And right now I can see the factors. The numerator factors as 2 times this trinomial there, and the denominator is already factored as 2x plus 3 times 2x plus 3. I can clearly see nothing factors. That is right, the best answer right there. Provided my numerator is correct, that I didn't make any errors when I was doing my multiplication and combining like terms. Good question. All right, so next we need to bring up a graphing calculator. So let's go here and get Desmos is cool too, don't get me wrong. All right, and then I'm going to shrink that screen so I can see. Just go side, please. There we go. Here and there. All right, so my original function, I'm going to call it f of x, and that is a fraction, and that is 3x squared. 2x plus 5, and the denominator is 2x plus 3. Let me get that right. Yeah, that's right. And then I'm interested in the points 2 comma f of 2, which is that fraction there, but we could get a better answer in just a moment on that. And I think Desmos is better with fractions than GeoGebra. And then we have our derivative function, so I'm going to call that d for derivative of x, our slope function. And we believe that one is fraction 2 times 3x squared plus 9x minus 8 divided by the square of 2x plus 3. All right, so that's the derivative function. And we want to know what the slope is at 2. So I'm just going to call it m, and m is going to be equal to the derivative when we plug in a, ooh, getting a fraction there. I bet up here, if I asked for what is f of, oops, f of 2, it'll give me a fraction. There we go. Okay, so that's kind of cool. So now I have the tangent line, if I got all this right, y minus the y value, 13/7, is equal to the slope, so I'm using the point slope form, 44/49 times x minus 2. And yeah, that looks pretty tangent there. We can zoom in. All right, so let's write that down, clean it up a little bit. 13/7, 44/9. So back here, new page, we've got the original function, f of x equals 3x squared minus 2x plus 5 over 2x plus 3. And we know this function has the point 2 13/7 when we plug into it. We know the derivative with respect to x of our function is 2 times 3x squared plus 9x minus 8 all over 2x plus 3 squared. And this is kind of a weird notation. Oh, I guess I could just write it this way instead. We'll say f prime of 2 we know is 44/49. So then the tangent line would be y minus 13/7 equals 44/49 times x minus 2. Let's double check that I copied all that correctly. Yep. So cleaning this up, we're going to have to distribute. And there were a couple of test problems like this where you're supposed to write it in slope-intercept form instead of point slope. You're supposed to write y equals. And so here, uh-oh, my battery's low. Fix that in a minute. So what are we going to get? We're going to get 44/49x minus 2 times that, which is going to be 88/49. And then we're going to have to add that 13/7 to the other side. And then we need a common denominator. So common denominator, we'll just multiply top and bottom by 7. And you can always do this on a calculator, like Desmos cleans up fractions for you. Let's see, what is 13 times 7? That is 70 plus 21, or 91. So we're going to get y equals 44/49x. And that would then be plus 3/49. Right? Negative 88 plus 91, or 91 minus 88/49. Yeah, so that's our tangent line right there. And then it's always a good idea to graph to make sure you got the right tangent line. So I should graph that version too, make sure it is the same one as I have here on my screen. So y equals 44/49. And so one thing I noticed on the test is it looks like sometimes you guys didn't have ways to check your answers. I don't expect you to get 100%, but I do hope that you'll find ways to check. And then what did we get? We got plus 3/49, and enter. If I turn the other one off, that is the same line. So it doesn't matter which one I call it, they are the same line. Cool. All right, let's try another one. So like the example that I posted, I'm going to start off with the function f of x equals, let's do product rule this time, and let's do x to the 7th power times the square root of x. Two options for the square root of x. One, you could use the limit definition of the derivative, or remember we did this in class and it was covered in the book. And if you look in section 3.2, it's like the first or second example they show using the limit definition for the square root of x, and the derivative is 1 over twice the square root of x. So I'm just going to use that result from 3.2. Product rule says take the derivative of the first function, so that would be 7x to the 6th, leave the second function alone. Product rule adds, not subtracts, and then leave the first function alone, take the derivative of the second function, which I have over there, so that would be 1 over 2 square root of x. And although some of the homework problems accept this unsimplified version, I expect you to simplify this. So let's go for it. First thing I would do here, I think, is factor out the common factor. And so we have, we can pull an x to the 6th out of each. And so that's going to leave me with 7 square root of x plus, and here, that's just an x is left. So I'm going to write it as x over 2 square root of x. Next thing I want to do is deal with this addition here, and there's a couple ways to deal with that. I guess the easiest one is to multiply top and bottom here by the square root of x and square root of x. And then we'll rationalize the denominator next. So what do we got? We got the 6x hanging out front. Square root of x times square root of x gives me 7x on the top over the square root of x. And then over here, oops, I forgot my 2, didn't I? 2 square root of x. Common denominator is 2 square root of x. So back here, I should multiply by 2 also. And that's going to give me 14x in the numerator. All right, that's an x down there. So, well, that's nice. Now I can add the numerators. So x to the 6th is still hanging out. And now I have 14x plus 1x is 15x over the square root of x. And I'm going to let's see, oh, I missed something. The common denominator is 2 square root of x, 2 square root of x, 2 square root of x. Okay, so now I'm going to rationalize the denominator. I'm multiplying top and bottom by the square root of x. And so that's going to give me x to the 6th, I don't need the parentheses anymore, times 15x times the square root of x on the top. And in the bottom, I have 2 times square root of x, which is 2x. So things clean up nice. X divided by x is 1. And that's about it. So I guess the final answer would be 5 halves. Let's pull that out in front. And then we have an x to the 6th square root of x. So this one cleans up dramatically from the first one here. And sometimes with the product or quotient rule, they clean up amazingly. Things cancel, move around, denominators disappear or reduce. Other times, it doesn't change too much. So like if we look back, did I get a mistake somewhere? Oh yeah, 15, thank you. 15, good call. Yeah, so check your work. How would I check this? Well, only ways to check it are to plug it in something like the derivative calculator to make sure the derivative calculator agrees. Derivative calculator even shows these steps. So if you're struggling with the algebra, look at the derivative calculator. All right. So again, how would I check this? Well, the only way to really check it again is like plug it into something like Wolfram Alpha or Derivative Calculator or some other app that does symbolic manipulation. And the other way to check it is just pick an x value and see if you can find a correct tangent line. So if I graph this here, I just pick an x value, find the slope, see if it works. And that's pretty easy with things like GeoGebra and Desmos. This one cleaned up a lot. So what constitutes a simplified answer? Well, usually a simplified answer, there's a few rules in math, but the simplest one is the final answer uses less ink than any previous answer. So I think this red version here uses less ink than the green version. Let's look back at this other one we did. Yeah, so here's, right, my first result taking the derivative right here. And my final result here definitely uses less ink there. And then, you know, we might compare this one here to this one here. I think this one uses slightly less ink. So based on my less ink rule, this would be an okay answer. Now the problem with this answer right here is it could be the numerator has a common factor with the denominator, and I don't know yet. So I really have to take it to that factored form for the numerator in order to know nothing cancels. So best answer, that one right there. So if this were on an exam, say it was worth 10 points, I might give 3 or 4 points for this here. I would probably give 8 or 9 out of 10 for that one, and this one right here would be a 10 out of 10 right there. So big part, homework, practice your algebra so that on a test, you're confident in your work when you do that. And then check your answer after. So if this question was here, just find the derivative, my check was finding the tangent line. And seeing if it looked okay algebraically. All right, let's see. I wanted to ask you guys, did you have any problems in section 3.3 part 2 that you wanted to have me look at with you?